Quadratics and completing the square. Now what we did last time was graphed quadratics, and I gave them to you in the form ax squared plus bx plus c. So I'm just going to give them to you in a different form, and we're going to graph a couple, and then I'm going to show you how to convert from one form to the other. Okay? Now, that converting to the completed square form is used in other courses for different things other than graphing quadratics. But really, the only application of it right now that we can do is graphing quadratics. But it is used in lots of other places in math, in other courses. So it's a good skill to know how to do it. And you actually use it if you go on in math in, I can think of an application of completing the square in sort of every grade or every level of sort of calculus that appears lots of times. So it is a good skill to know. So this is what we did last class. And if we give a quadratic in a completed square form, it will look like this. Now, if we take this x plus 1 all squared, that's x plus 1 times x plus 1 minus 4. We can FOIL I'm just rewriting the minus 4 because that was on the end. So what do we have here as a quadratic in standard form? X and x is 2x, 1 minus 4 minus 3. So we can convert easily from this form to our standard form. Easy, you just work it out, okay? The problem then becomes, how do we get from here to this one? And that's a little more complicated, okay? So that's what we're going to do today. First, let's just look at this equation. So y equals x plus 1 squared minus 4. So there's a few good things about this if we're using it for graphing, and that is that the vertex is found by whatever is in that bracket squared, setting that equal to 0, gives me the x value of the vertex. So negative 1. And the y value of the vertex, we don't need to plug it in because why? If we go to plug that in, so whenever, just like last time, if we find the x value of the vertex, we plug it in and we get the y value. So if we plug this in, what do we get? That's 0, isn't it? Which is actually how we found it, was setting it equal to 0. So that's 0. So y is equal to minus 4. So actually we just need to look at this and say, okay, what makes that 0 is negative 1, and this number is the y value, negative 4. So the vertex we can read off of it quickly if we needed it. Now, if that's the vertex, how do we graph the rest? What do we need to do? We need to find another point. We could do a table of values or something like that, but we really want the intercepts. So, the y-intercept is always easy. What do we do? X equals 0, and plug that in. 1 squared is 1. So a few people that came for help weren't writing their intercepts as points as soon as you get it, and I said that was really important for not making careless mistakes, so make sure you do that. So I found the point and I wrote it down right away. Okay, I didn't just leave it as a minus 3. Now what about the x-intercept? Y equals 0. Now we're going to do this two ways. You can choose which way you like better. Okay? One way is going to look confusing, but I prefer it. It's a little quicker. And the other way is probably the way a lot of you will just choose to do it to not make any mistakes. Okay? So this way, we're going to just leave it like this. The second way will give us the same answers. So any ideas, first off? What's that? Yeah, that's my preferred way. This is difference of squares. Remember I said any two things with a minus sign in between, we can do difference of squares? And then what might be the other way? No, we don't want to ever do that, because we'll miss the plus or minus. So I'm not even going to say out loud what you said. If someone else says it, I may. What would be another option? The hint is up above, still on the screen. If we FOIL it out, this is the equivalent equation, it just looks different, right? So we could, our second method would be to FOIL this out, and then subtract 4, and we would get x squared plus 2x minus 3. And then we can either factor or use quadratic equations. Okay, so that's the method I see most people using, because this, sometimes they don't want to. But let's complete the square, or use difference of squares for this one. So what would the two squares be? The square root of x plus 1 squared is just x plus 1. Square root of 4, 2. 1 is plus and 1 is minus. Neat, eh? Plus 3, x minus 1. Okay, do you see it? Now this one, if we factored it, what would we get? Two numbers that multiply give 3, 3 and 1, add to give 2. Same thing? Okay. So either way, difference of squares. The benefit of knowing that difference of squares one is what? If that were a plus sign, what would we be able to conclude? Sum of squares doesn't factor, means there's none. And you would know right away, you wouldn't have to FOIL it out and try to factor and then use the quadratic equation and then realize it didn't work. You would just stop right here and say sum of squares doesn't factor. That means there's no x-intercepts, and we can go on and graph it. Okay, so there is a benefit to it, to not always sort of jumping to just working it out and trying, is that you do cut some work out if it doesn't work. So difference of squares. But I'm going to try to confuse you in a minute. So, okay, now I don't want to stop there. I want to write these as points. Make sure they get written as different points. Y is 0, so x, we've got our two x values. Now we can graph. So put your vertex in first. So what's our vertex? -1 and -4. Just going to look at my other points, 0, -3, -3, 0, and 1. Okay, so this should do it. So your vertex, -1, -4. So -1 on the x and down. -3, 0, and 1, 0. And -1, oh no, and 0, -3. And then you want to sort of look and say, does it look symmetric? Does it look the same on both sides? We didn't have that equivalent point, but we could put it in if we wanted to. Okay. Okay, our second one. So this is actually our last one that I'm going to set up for you, and then we're going to actually convert it to this form to see how that works. Okay, so this one, is it sum of squares or difference of squares? Sum of squares. So this one will not have x-intercepts. And you know that right from the start, and that's because the plus sign. Okay. We've got two things that are added, one with a square, or both squared if you want. Okay, so that will be sum of squares. If you worked it out and tried to factor, it won't factor, and then you say, okay, well, I'll use a quadratic equation, and that won't work either. Okay, so let's just jot that down. Sum of squares doesn't factor and has no solution. So, won't have, which intercepts? X-intercepts. And what does that mean about the graph? If it doesn't have x-intercepts, how can it not have x-intercepts? No. Right, the graph is above the x-axis and open upwards, so it goes up and it doesn't go down through. What's that? Yeah, it could be facing below. We didn't do those yet, but yeah, so a parabola can actually open down this way. Okay, but we'll do that in a minute. That's our next example. So, what's the vertex? Remember how I said to read the vertex? What makes that 0? 2. And if that's 0, it's gone, and the y value be 1. Just 1. Okay, so this is x minus 2 equals 0, gives this one. And that value just, because if this is 0, it's gone. So there's our vertex. Our y-intercept, we let x equal 0. So minus 2 squared, 12 plus 1, 0, 13. So far, so good? Now, we're not going to do it because I just said here it's not going to work, but if you didn't recognize that or you don't want to think about that, then what you do is you multiply this out, FOIL, multiply all those terms by 3, add the 1, simplify it, then try to factor, it won't factor, then use quadratic equation, you'll get a negative under the root, and then you can conclude what I already concluded. Okay? So that's why there is some benefit to looking at it this way. All right, do we need more points than this to graph it? Since there's no x-intercepts. No, we don't. We need the vertex and at least one other point, because every other point is symmetric. We can draw it just with that. So, our vertex, 2, 1. And we have to go up to 13 here. So maybe draw your graph a little lower. So 13, I'm going to stick it up here. What's that? Oh yeah, yes, the symmetric point, yeah. Yeah, so this is our vertex. And what would be the symmetric point if you wanted a second point, so you could draw it and would look symmetric? Here's sort of the middle. How far is that over from 2? 2. So if we go 2 in this direction, where would we be? 4, and the same height. So 4, 13 would be over here. Okay, without plugging it in. You could double check by plugging in 4, and then you get the same answer, 13. Whoops. And if you miss the point, just make your point bigger. There we go. If you look at my solutions ever, the ones with the great big points, you'll know that's what happened. Okay? And that would be it. All right, so let's learn how to change an equation from standard form into completed square. Okay, we're going to start with one that just works out easy, has no tricks in it, and then we'll add a little bit to it for the next two examples. So we're going to write this as steps, okay, and then I'm going to explain why the steps work, okay, when we look at the final answer. So we're going to write down step 1, 2, 3. That'll help you work your way through. Okay, so step 1, I'm going to do it in different colors. Step 1. Okay, so remember I said you need to have the English in your head of what the steps are. So I said rewrite it, that's my step. What did I do when I rewrote it? I just left a space, okay, because we're going to do something in that space. So what did I leave a space between? I put the two first terms with the A and the B, and then I just moved the C off to the side. Now why did I do that? Now we're going to go back to our notes. Right here, remember we're going backwards from this form, okay, this form back up to here. Look at the next step. Where's the -4? It's way over at the end. That's the -4 that's here. Okay, so we're kind of moving that over so that we can fit some pieces in here to go backwards. Okay, so that's all we're doing first. So we rewrite. Step 2. Take the coefficient of the x term. Okay, that's whatever's in front of the x, that coefficient. We're going to take that number with the sign, don't forget to take the sign, it's a plus here, and divide it by 2. So what we end up with is +4 divided by 2 is equal to +2. Okay, that's it. That's step 2. Okay, and I'm going to do the next step before I show you why we're doing that. So this is the actual step. This is the first step. Rewrite it with a space. And step 3, add, then subtract. Add and subtract the square of the number you found in step 2. So what's the square? What does that mean? So you're going to take +2 and square it, which is what? 4. So we go back, and you're not going to write all these words out as you do it, so it'll be much quicker, because you're just going to go back up here where you left a space, and you're going to add and subtract 4. So we'll rewrite it how we had it, because I want it to look in order so you can see what happened. But we had that from step 1 with that space. You're going to add and subtract the 4 right in here. Okay? Now why can you do that? Does that change the equation? It just changes the way it looks. It's like a disguise. Because if you add 4 and subtract 4, what does that net? What is that? Just 0. So we didn't add anything, really. Okay, we're just making it look different. We're splitting it up. It's like the foil thing. Okay, now this is good. Step 4 is to factor the first 3 terms. It is now a perfect square. Do you remember what a perfect square is? Oh, you'll see in a minute if you forget. So these are the first 3 terms. I just put them in blue. And the last 2 terms I'm ignoring. okay, these two numbers, but the first three terms right here, how would we square that? Two numbers that multiply to give 4? And add to give 4? 2 and 2. It's a perfect square, so they have to be the same two numbers, or else you messed up. And then, what does this equal? No, minus 4, negative 8. Okay, so I factored this, x plus 2, it's all squared, it's a perfect square, minus 8. So our vertex is the point -2, -8. We just read that off. What makes that 0? -2 and -8. And we could go back to the beginning to find our intercepts, or we could use it here. It has them because it's a difference of squares, so it will have them. I'm not going to draw it. I'm just going to do more. We know how to draw them now.
Would you get the vertex -2?
Yeah, it's what makes that 0 and that number, right? Yeah. So you can read off the vertex here. Last class we did the formula minus b over 2a. You can still do that if you want to, but you have to go back to this start form to do it. Okay, so let's do one with writing all those steps. Okay? Oh yeah, so I forgot. Why did we divide by 2 and square it? Any ideas? Well, yeah, it is to get this, like here, that gives us, when you add these together, it's 2 times x. So we divided by 2 to break that up into 2 pieces. It's like going backwards. So here, 1 plus 1 is 2. If you divide by 2, you get the x. And that's what we're doing, is working our way backwards. So hopefully it'll become more clear in the second example. So the second example, like I said, I'm adding a layer, a little bit harder, okay? So, example 2. Okay, so step 1 is still the same, just rewrite it with a space. Okay, and that space is to add and subtract a number, right? We just need to figure out what number that is. Now, here's the difference. This one has a 2 in front of the x squared. The coefficient of the x squared is 2. For this process to work, you can't have a coefficient other than 1 in front of the x squared. So there's one more step in step 1 when you rewrite. We're going to factor out the 2. So if we factor out the 2, what do we get here? X squared, factor out the 2, 12 divided by 2, 6. And that 2, you don't need to factor it out of that. And sometimes it won't even factor out. Okay, so I want you to look at this. Do you see what I did? I took the 2 out of this part so that that x would not have would have just a coefficient of 1. Okay, so I factored a equals 2 out of the first 2 terms. You could factor it out of here if you wanted to, but a lot of times it won't work, so I just don't bother. Okay, and then my space is still here. Step 2 is to take the number in front of the x and divide it by 2. Which will give us what? 3, and then square it. So 3 squared is 9. Then that 9, we add it and subtract it. Okay, so all of that stuff that I wrote on the last page is this. Leave a space. The new step here is factor out that 2. Take the number in front of the x, divide it by 2, and square it. That gives us 9. Add first, then subtract. Okay, and then what's the next step? I'm just going to rewrite it here. You don't need to. You don't have to rewrite it. I'm just doing it to make it a little bit easier to see. Okay, so what we do is take this first 3 and we factor it. It's a perfect square. What are the two numbers? 3 and 3? They multiply to give 9 and they add to give 6? So when I rewrite it, very carefully, I just made that bracket exaggerated so you could still see it. That's around the whole thing. This one I factored. The minus 9 is still there. That wasn't part of the factoring. Now I need to first get the 2 back in to get rid of that bracket. So we're going to multiply this by 2. Don't put it in the bracket, that's not a thing. And then 2 times 9. Minus 18 plus 2? Minus 16. So this 2 is in front of that bracket, which has 2 terms in it. So it goes with that one, which we just write in front. A number in front of that squared bracket, or in front of the x squared, just actually makes the graph narrower. It doesn't really matter. You plot your points and it will just look narrower. Okay? And then times 18. That 2 is out of the bracket, so it's still there. So you can take the 2 out of here, or at the beginning?
At the bottom.
Oh, at the bottom.
2, 16.
No, you don't want to factor it out because we're not solving for x, right? This is an equation, so good question. You don't want to go too far. This is y equals, and then you would graph it. The 16, the vertex is, the 16 is part of the vertex. It would be minus 3 minus 16. Right? If you factored that 2 out, you just aren't going to see it because it's not in the completed square form. So you need your square with or without a number in front, and then your y value of your vertex. Okay? Now, and then you can draw that. Does this have intercepts? X-intercepts? Yeah, then there's 2 ways to know. First of all, this is going down, so it's below the x-axis, and it will go through the x-axis as it goes up, right? Okay, and it's a difference of squares. Now, the third one, we're going to talk about when a parabola opens downwards instead of up. Okay, and there's lots more examples in your textbook, so you look at those too if you need more examples. And I've written the steps out for the completed square in the textbook, so you can follow that process too and see for a different example. When does the parabola open downwards instead? Do you remember from high school? When what's negative? When A is negative, yeah. So so what you don't want to do is, by mistake, is just like change all the signs. You can't do that unless you're solving for x. That was a technique when there was a 0 on the other side. Okay, if you change all the signs, you're changing the y to be a negative y, and then that changes all your points. You can't just get rid of the negative, okay? So what we did in this last example, when A was not 1, A was a 2, we're going to do the same thing here. It's negative 1. We have to factor it out first, just like we factored out the 2. Okay? So, and we'll go through after we complete the square and graph this one, because we didn't do one that opened down yet. So step 1 is to leave that space. And we can't have a negative or any number in front of the x squared, so we're going to factor that out. What happens when you negative 8? Don't worry about the plus 2, leave it outside the bracket. You could change the sign and put it in the bracket, but I find people make more mistakes that way, so that's why I put it there. Okay. Now what? Now you're just working inside this big bracket. You're going to take the number that's in front of the x, minus 8, and do what to it? Divide by 2 and divide by 2 and square it. So minus 8 divided by 2, negative 4. Negative 4 squared, 16. What do we do with the 16? Plus 16 minus 16. Then you factor this first part. So this 16 we added and we subtracted. I'm going to rewrite it just to make it easier to see.
Is the order specific?
Yes. Add first and subtract. You won't get a perfect square if you put the minus first, because then you can't multiply the same two number and get a negative. Yeah. Has to be plus first. I mean, you're not changing the equation if you put the minus first, you just won't be able to do the next step. You won't be able to factor it. Okay, so what does this factor to be? X minus 4. It's always the number right here before you square it. Always. Still, we've got that big bracket with that minus 1 in front. Now what do we do with the minus? Just like the 2, what did we do with it? Put it back in front of the x squared, and then with the 16. So we'll have minus x minus 4 squared, that's putting in front. Don't change the signs inside, that's not allowed. You'd have to FOIL it out and change all the signs to do that, and we're not doing that. And then minus and a minus, plus 16, and then there's a plus 2 at the end. So what's our answer? Okay. Now my question is, does this have x-intercepts? Yes. So anyone else? Does this have x-intercepts? It does, but I wanted someone to say no. I was hoping someone would be wrong. Why does it look like a sum of squares? It does because of that minus sign in between, but you have to be careful. We talked about this before. If the x is negative, like this is still a difference. We're subtracting these two terms. If both of them are positive, then it is a sum of squares you're adding to. But this is subtracting. I know you don't like rewriting it with that second, but are these the same thing? Right? It is, and it is a difference of squares. Okay, it's just not as obvious. You would flip it this way, and then when we factor this, so if we wanted to find the x-intercepts by letting y equal 0, how would we use difference of squares, that technique, to factor this? Square root of 18? Yeah, it is root 18, like that 16 works, and right, but 18 doesn't. So what would we have? Root 18. And what's the square root of this one? X minus 4. You can put a bracket around it if you want. And then root 18, x minus 4, right? Square root of 18 is root 18. It doesn't work. We can reduce it, but let's not worry about that. And the square root of that. And then what do we put in between? 1 plus, 1 minus. This is kind of weird. But I'm going to do it, this would be minus x plus 4. Do you see it? So here we've got probably you would write this as x plus root 18 minus 4. And this one you would write as root 18 plus 4 minus x, maybe. I don't know. All right. This is very weird. We're going to do it the other way in a second to show you it's the same answer. What's the x values here? If we set this equal to 0, we get x is equal to, move the 4 over, minus root 18. And here, move the x over.
Why is it plus 4? Right.
So now we have 4 minus root 18, comma 0, and 4 plus root 18, comma 0. What do those, where would these have come from if we had done it the other way? Quadratic equation. We would have had plus or minus root 18 when we did the quadratic equation. You could reduce, I would probably reduce it further, right? What's root 18? 9 times 2? Square root of 9? 3? So this would be 4 minus 3 root 2. Okay. So the other way to find the x-intercepts would have been to take our original equation, which probably would be easier in this case than doing that. Set it equal to 0, because the x-intercepts we let y equal 0. And then I would probably move everything to the other side. And then it doesn't factor, so you'd use the quadratic equation, and then you'd end up with the same things. Okay, this doesn't factor. And just before you pack up, let's just go to the factored form of this one, which was minus x minus 4 squared plus 18. What's the vertex? What makes that bracket 0? 4. And then 18. We've got our intercepts that are strange numbers. And what about our y-intercept? We let x equal 0. You could go back to the original if you had it. It's actually easier to plug in 0 there, but here would be okay. Minus 0 minus 4 squared plus 18. 4 squared, 16, plus 16 with a minus in front. 2. So 418 is up here, and 02 is down here. And these points would be which we don't actually need to draw the graph. If we have another point, right, we'll know goes, mine should maybe look a little bit more symmetric than that, but. So, do you need to know that the minus in front of the x squared makes it flip? Yeah, that's really good to know, but when you find your points, it will show you that. When you plot your points, your vertex will be higher up than your other points, and when you draw it, it would be flipped. Okay, so we're all done that section.